So hi everyone, my name is Daniela, and thank you for joining my talk. Today I would like to speak to you about how we achieved more quality by testing less. And this is all thanks to strategic testing. So you might ask, but what is strategic testing? And I would like to share with you a quote, which I believe sums up strategic testing quite nicely. And it goes like this. So quality is never an accident. It is always the result of intelligent effort. And strategic testing is exactly this. So you need to do a bit of an assessment of which tests give you the most value and test only those. So this presentation will be about my own personal story when back in 2022, I was approached by the CTO of a company to help overhaul their testing processes. Even though they had a QA team in place and also some testing, which was always passing, they still had a lot of issues on production. And this was not the desired, of course, approach. So as you might assume, my first task was to identify the problem. So why were they doing the testing, but they still have a lot of bugs on production? And I could identify some problems, which are highlighted on this slide over here. And basically, I could notice that they had too many tests, and because of this, it was difficult for them to keep up with all these tests. Apart from this, their automated tests were also flaky, unfortunately, which was also causing a lot of manual testing. And because of this, they also had a slow release cycle because manual testing was taking up a lot of time. And apart from this, as I already mentioned, they were having a lot of persistent bugs on production. And if we had to break down the problem a little bit, we would end up with this diagram over here, where basically we could see that they had too many tests, plus flaky tests, which was causing a slow release cycle and also persistent bugs on production. But if you look a bit closer, you would say, how does it make sense that they had too many tests, but still a lot of bugs on production? Shouldn't it be that if I have a lot of tests, I should have a lot of coverage and hence no bugs? Unfortunately, this diagram proves that it's not the case. So what was the solution? And we could come up with this three-step solution. And basically, the first step would be to identify a new list of test cases, but this time they need to be simplified and relevant. Simplified for the simple reason that they can't have too many tests and we can't keep up with them. And they also need to be relevant, because even though we had a lot of tests, they were still not finding the bugs that we wanted them to. That meant that our tests that we had were not relevant. So we need to keep that in mind this time around. The second step would be to automate these new test cases, but this time we need to keep robustness in mind. And this is because, again, as I already mentioned, they had flaky tests. So even though they had them automated, they were flaky and they were causing a lot of manual work. So we need to keep robustness in mind this time. The third step would then be that if we have step 1 and step 2 in place and working properly, we would be able to start transitioning to a faster and more reliable release cycle. So if we had the automated tests in place, which are simplified and relevant, and also we have a robust test framework, this would mean that we can have a faster release cycle because we're not doing a lot of manual testing, and also the tests would be also reliable. So this means that hopefully we don't have a lot of bugs on production. So if we take a bit of a closer look onto the final details so we can understand the implementation later. So we had 4 main teams, which were full stack teams. And this means that every team had both front-end and back-end engineers. And every team had either a test analyst or a test engineer. And if we look a bit into the testing responsibilities of the QA team, they had 3 main responsibilities. So the first one was release testing, which included both manual testing of the tickets and also the regression. And this was a responsibility both for test analysts and also test engineers. The second responsibility was then to do manual testing of all the sprint tickets. And again, this was a shared responsibility between test analysts and test engineers. The third thing was automation development and maintenance, and this was only a responsibility of test engineers. And now on to the interesting part, hopefully, which is the implementation. So how did we implement this solution? And we split our implementation into 2 main phases. And the first phase is highlighted just over here. And it included 3 main steps. So the first step was to come up with a new list of test cases, which we called critical paths. And to do this, we met with the product owners of each and every team, and we discussed with them which features were the most important for their own team. Once we met up with the product owners of each and every team, we came up with a consolidated list of test cases for the whole product. The second step was then to document these critical paths. And we documented these critical paths on a test management platform, which also served as replication steps for our test analysts. And the third step was then for the test analysts to execute these tests manually until they could be automated. So I've been mentioning tests and critical paths, but what can you identify to make a test as a critical path? And I would say it has to satisfy one of these three criteria. So the first one is if this test fails, it is considered as a blocker. As you might have experienced in your career, sometimes we have tests which fail and we don't really care about those. And that should give you a strong indication that that is not a critical path. So that should not make it as part of this list. The second criteria would be any regulatory requirements that you have. So every company is usually based on some sort of regulations, and we need to make sure that this works, because if it doesn't, it might also cause for us to lose our license. So it's very important that these things work. The third thing would then be any functionality that is crucial for your business. Now, this, of course, depends on the different business types that you have, but you need to do a bit of an assessment for your own business, what functionality is the most critical. And if we had to go to some practical examples of what are critical paths in real life, we can have, for example, a login. And usually, if this fails, it is actually considered as a blocker. So it's very important for this to be a critical path. And usually, the most important functionality is always behind the login, because we need it to be secure. So for this reason, it's very important to include login as part of your critical paths. The second example would be a cookie policy, which again is usually a regulatory requirement and is very important for this to work on production. And the third example would be payments. Now again, this depends on, of course, your business. However, every business usually relies on some form of payment coming in, so it's very important, of course, that payments work on our system. And when it comes to types of critical paths, we split our critical paths into two main types, which were smoke and sanity. And when it comes to smoke tests, these are usually preliminary checks used to identify major issues. And if these checks fail, usually we consider our system to be on fire, and hence the name smoke. And sometimes you also refer to them as shallow testing, and the main aim of these tests is to make sure that the most important parts of a system are working before doing more in-depth testing. When it comes to sanity testing, then these are usually tests used to identify major issues in our system. And if we have to add these two types of tests together, we'll end up with our regression suite. Now, if you had to ask, so if I had to go back to work today, how do I come up with my own list of critical paths this time? And I would like to offer you 4 main tips on how you can achieve this. So the first tip would be to pair up with someone who has deep product knowledge. So usually, the product people in your company would be able to help you to identify those types of tests. The second step would then be to identify any problematic areas which are usually currently not being covered. So you might see that when you come up with your own list of critical paths, you are still having some bugs on production which currently are not being covered. For this reason, you need to do a bit of an assessment and see exactly why, because you can have some areas in your system which, even though initially you might not seem this as critical, it could be an area which is more prone to breaking because, for example, you have a lot of changes in this area. So that automatically makes it more prone to breaking, and you ideally add this to your critical path list. The third step would be to identify areas which are currently crucial for your business for different reasons. It could be regulatory, it could be fundamental requirements, or also any features which generate the most revenue. Again, usually the product people can help you identify these types of tests for you. And the fourth one would be to structure your tests in an end-to-end fashion. So if you structure these tests in, for example, a component level, this would for sure make your list much bigger. And apart from that, it would not be mimicking the user experience. So when you keep end-to-end paths, this would also be mimicking the user experience, which at the end of the day is what we strive for on production. So when it comes to documenting the critical paths, we use TestRail as our test management platform to document our test cases. And TestRail offered us 2 main functionalities which we're most interested in. So the first one was that it, of course, allowed us to document our tests by providing replication steps and also assertions for each and every step. And apart from that, it also gave us the functionality to create test runs. And test runs is what we're seeing here on this slide, which is basically a copy of the test cases, and it would allow you also to mark each and every test case as passed or fail, and it would also give you visibility of your testing efforts by providing also percentages of where you are with your testing. And if you share this maybe with some other departments in your company, you would be also allowing for visibility for your testing efforts for your team. So by the end of phase 1, releases looked something like this. So we had weekly releases, and the test analyst executed all the regression tests manually. And in fact, the regression time took approximately 1 day, because everything was done manually. And in phase 2, we mostly focus on when the test engineers automated this regression suite. And for the implementation, we chose TypeScript and Cypress as our technology of choice. There was one main reason behind this decision, and it was mainly because our front-end engineers were already familiar with these technologies. For this reason, if we needed any help with any testing, the front-end engineers would have been able to help us with minimal effort. And when it comes to challenges from this whole presentation, the phase 2 was the most challenging. And this was because it was very tricky to manage time. As we saw earlier, our test engineers had a lot on their plate. And even though they had to do the automation, as well, they had to also take care of a team as well as regression. For this reason, managing time was proving to be quite challenging. And for this reason, we introduced 3 new ways of working for our test engineers so we could help them manage their time better. And the first thing that we introduced was the quality assistance model. And basically what we did here is we coached developers on how and what to test for their code. And this was mainly achieved by including the test engineers and the test analysts earlier in the process so that he or she could come up with a test plan and the developers themselves would execute this test plan post the implementation. We found this mostly effective for major features, and it was proving to be quite effective. The second thing which we implemented was to empower test engineers to push back. As you might have experienced in your career, sometimes, unfortunately, developers do ask for some extra reassurance for their work. Unfortunately, we did not have this luxury when it comes to resources, so we had to push back on some of these requests. And this was mainly effective for minor features. The third thing which we introduced was the 70-30 rule. And this was a rule which we implemented mainly for the planning phases, where we asked test engineers to spend 70% of their time on automation tasks and 30% of their time on manual tasks. This was not always possible due to also some deadlines, but keeping this in mind during the planning phases proved to be beneficial for us. So earlier I mentioned that we need to keep robustness in mind when it comes to test automation, and I would like to offer you some tips to keep this in mind when you do your test automation. And the first tip would be to, where possible, always use APIs for test setup and test teardown. This is very important to keep in mind because it would make your test very, very reliable and much slower. The second tip would be to avoid code application. We all know how code application can be tricky. And when it comes also to test automation, this can make your tests flaky, because even when it comes to maintenance, for example, you might fix one place and not the other. And for this reason, it might make your tests fail even further. Also, to avoid static waits. Static waits are very dangerous, and especially in test automation, it would make your tests flaky, because rather than waiting for a specific element to show up, you're waiting for a number of seconds, which might cause for this element not to show up, and your test would fail. The final thing is to use maintainable and unique locators where possible. Ideally, we always use IDs, but these are not always available, unfortunately, so in that case, you need to find alternative ways on how to achieve this. An example would be to use XPaths using a class and a text so that you would make your locator unique. And when it comes to execution, on how we executed these tests, we executed them into 2 main ways. So the first thing was that we had automated nightly jobs. So we had this cron job in place, which would run during the night. And the first thing our test automation engineers would do in the morning is to monitor these tests. Usually, if one of the tests would fail, it is usually a blocker because, as we said, all the critical paths are blockers. So we would investigate them in the morning, and if we find any blockers, we would report them early in the day, which would sometimes allow us to still go ahead with a release later in the day because it would be fixed already. The second step is to manually trigger them before a release. Because of different issues, the release did not always happen at the same time during the day, and for this reason, for us, we used to manually trigger them before the release. And by the end of phase 2, releases looked something like this now. So basically, we had daily releases this time around. We also had the regression, which was fully automated. The test analyst executed only the failing tests, and the regression time took approximately 1 hour this time. And I'm not sure if you can notice any improvements when comparing phase 1 and phase 2, but thanks to the automation efforts which we did in phase 2, we could see 2 major improvements. So when it comes to release frequency, went down from weekly to daily releases, and when it comes to regression time, went down from 1 day to 1 hour, which should be a major improvement, right? And post the improvements, the testing responsibility looked something like this now. So basically, when it comes to release testing, we did only the regression. So we no longer tested all the tickets because this was being done by the developers themselves, as explained earlier in the quality assistance model. And when it came to manual testing, we did that only for major feature rather than for all the sprint tickets. And of course, test automation, development, and maintenance remains unchanged. And basically, a year later, we could notice all these improvements. So we're catching issues quite early. We also had a maintainable test suite, and because of this, we had little to no test failures. We had significantly faster regression. We also had daily releases now, and thanks to all these improvements, it allows us to start transitioning to CI/CD as well. And we also noticed some other positive impacts, which was more focused on the human aspect this time of our team. But basically, we could notice that the organized work environment that we had was boosting the motivation of our team. Apart from that, since we had reliable automated tests, we were having a lot of free time. And because of this, we could invest this time around. Instead of boring tasks, we could invest in ourselves, and also we could learn and self-improve and spend this time on self-improvement. And some future plans which we had was basically mobile automation. So everything I've explained so far was done for desktop. And we had the plan to do the same thing this time for mobile. Apart from that, we also wanted to do the same as well for API automation. This time round, we wanted to do exactly the same tests for critical paths and identify which APIs are the most critical for us, and implement those in the form of automated regression. And as a recap on this presentation, I would like you to remember 3 main points. So the first one is that more tests do not mean more quality. That means quality over quantity. The second step would be test automation does make a difference. So we could notice the improvement between the end of phase 1 and phase 2, and that was all thanks to our automation efforts. And the third thing is an organized work environment does boost the employee well-being, and you should really appreciate this because your team will only work depending on your motivation. So it's very important to keep your human aspect in mind when you do any improvements in your team. And this brings me to the end of my presentation. Thank you for your time, and please let me know if you have any questions. Thank you.
Daniela, congrats. Congrats. I think you did a really good job with your speech. Right on time, and 17 questions. Look at that. So, yeah, now you can take a little bit of breath, and I will read you the first question. So what to do if a product owner thinks everything is critical and does not want really to cooperate on this?
Unfortunately, this is quite common, I would say, and I also encountered this in my experience. However, you need to explain to them the value of having less tests, because we also need to keep maintainability in mind. Sometimes, of course, product owners would think that everything is important because the product is, of course, important to them. However, you need to explain why this should not happen. And if you explain this and make it clear to them and keep value in mind, then they should be able to cooperate on this. Or tell them to come to this conference.
Okay, the second question is from Steve Watson. How did you carve out time to rewrite the tests alongside testing the sprint tickets?
Yeah, again, so this is why we introduced the new ways of working. It wasn't very easy, I would say, but to have like a lot of things to do at the same time. However, trying to balance a bit your time between manual tasks and also automated tasks would really help you with this. And also, you need to, again, explain the value of why we're doing this and why we should not spend a lot of time on the other work, because this, in the long term, would give us more value.
Okay, from Mark, we have two questions, really. So do you think critical path testing is enough in the long run? Did you have other plans going forward?
So for now, critical paths were serving the purpose for us. However, I do agree that this is not enough in the long run. So it's very important to keep other things in mind. Like, for example, we also mentioned, for example, mobile automation, but this time also APIs. So again, you should strive a balance between API testing and UI testing, because you can't have everything automated on the UI level. And this is why one of the next plans that we had was APIs, because that would also help you test on different levels as well, and also keeping maintainability in mind and also flakiness.
Okay, says when did you test non-critical paths?
So mainly this was done for the sprint tickets, I would say. Of course, if you test a ticket, then you would not test only critical paths, because critical paths were mostly done during the regression. And when it came to the ticket testing, of course, we did test non-critical paths relating to that particular ticket.
Okay, the next question is what I would have asked also. So did you find any resistance to this approach? So was it hard to implement it, or did you find anyone who said, no, don't do this? Or
yeah. So I think that any change that you try to introduce will be coming with resistance, unfortunately. But again, I do think that if you explain the value enough, then it would allow you to get the support that you need. And because of this reason, I think that you really need to explain the value properly to get the resources that you need, after all. And apart from that, you also need to explain why we're doing this as well, and to prevent them from ending up in the same loop again that we had, which were not keeping up with this test, after all.
Thanks. Implementation phase 1. Why test analysts executed the tests?
Okay, so as I've explained, our QA team was basically had test analysts and also test engineers. And since the test engineers were mostly focused on implementing these tests in an automated way, then test analysts unfortunately had to help out with this. And this was the main reason behind this.
Okay, I think we have for 2 more questions time. So from Zed, how big should be the QA team to make this testing strategy work in a regular squad or team?
I think it all depends on how many development teams you have, of course. But I think 1 QA should be enough for all this. But going forward, if you also want to include maybe non-critical paths, 1 QA will not be enough. However, if you have the quality assistance model where the developers would also be able to help you with your tasks, then I think that 1 QA should be enough for every team.
Okay, and the last one, do you review and discuss the tests around the critical paths with the BA or system analyst once created? What happens if the requirements change midway?
Okay, so yes, definitely we did review our tests around with the system analysts. Of course, if the requirements change, you would have to revisit your test plan. And unfortunately, this is something quite common in our industry. So yes, you do need to revisit when needed, of course, especially if the requirements change along the way.
Okay, thanks. And last question, are you here today all day on the conference?
Yes, should be.
Okay, then 13 questions left, so please find Daniela where she is and you can ask him in the breaks or at lunch. And another round of applause for Daniela.
Thank you.
Thank you that you were here with us.